computer. Okay. Okay, so you do want to review this page 1 and just really absolutely know these. The rest of this, these are my Chem 107 lecture notes. And this is what we do for the Chem 107 when I teach it. And you guys don't have to do all this. They did. But oh yeah, see, I had oodles on here. But I wanted to include all the pages because there's a really nice, oh, this part's nice. This is really helpful. It's a good review for you. And then you're going to want to know your diatomics for sure. So this is a good nomenclature review. Okay, this is just for Chem 107 to practice. Yeah, we did like oodles of worksheets. Yes, a million gazillion worksheets. Oh, this is what is really good. Okay, so I included all of this because there's a very nice table here. So you see, it's got the common ions and look, it's got the charges. So we're going to see a lot of these. And notice that there's sometimes you have situations, for example, the manganese. Look at all these different oxidation states that are possible for manganese. We've got different possible oxidation states for nickel. So we are going to see, these are the common ones. So you're going to want to understand these because we will see them. So that's a very nice table I wanted to include in here. And then this is just the naming, which would be good review for you, but I wanted to include that table. Okay, so now, so now we will start with the chapter 18. And so you can see that I put here, yeah, you want to know your oxidation numbers. And what we're going to do is we're going to do some balancing. And for this electrochem, we are not going to worry about the phases. They do exist, but we're going to focus on the oxidation numbers. Okay, so what we're going to have to do is we're going to start by this first step 1. We're going to assign oxidation numbers to the atoms which change. So sometimes when you're starting this, you might have to assign every single oxidation number to find the ones that change, and that's fine. When you see an oxidation number the same on both sides, that's not the one we're interested in. So for example, this is H+1. And then on this side, it's also H+1. So that's not the one we're interested in. We're interested in the ones that are different. Okay, so what you guys are probably going to have to do is you're probably going to have to assign all oxidation numbers on a piece of scratch paper. So this is the way you would approach it. That you would go ahead and assign all oxidation numbers on the scratch paper. And then we're going to focus on the ones that change. And in a situation like this, we're going to have to go backwards and figure out the nitrogen. So the way we would do that is we would start with the hydrogen +1. Let's say we don't know this yet. Okay, we don't know this one. We're trying to find this one. We would start with knowing the hydrogen is +1, and we would know each of the O's. This is -2, -2, -2. We're going to go with what's most common for oxygen. We know that we add this up, so we just add all of them up. And we get a -6. If the negatives are -6, then this has to be a +6. We already know this is a +1. So what must this be in order to add up to +6? +1, that makes this a +5. So you have to go work it out. That's how this was a plus. That's, oops, okay, that's how this got to be the +5. So we put the +5 is for the nitrogen. And we had to work out the copper was a +1 because we know the oxide's a -2. The copper, then this side must be a +2. But there's 2 of them, so each has to be a +1. Okay, so this one, what I did is I said to myself, nitrate. I know my nomenclature really well. And I know that a nitrate ion is a -1. And we have 2 of them. And that's how together they are a -2. And that's how we get the copper to be a +2. So I left the nitrate together because I know nitrate's a -1. That's pretty much how you have to work this one out, is leaving the nitrate together as a -1. And that gives you the -2. And therefore the copper is a +2. And then this one, I know the O. I know this is going to be an oxide. And so if this is a -2, this has to be a +2. The step 1 is critical. For this chapter, the step 1 is absolutely critical. Okay, you can't even tell what that is. That was supposed to be an arrow. Get rid of that. Oh, okay. Any questions about figuring out all these oxidation numbers? Does anyone need more time copying this down?
Do we need to find it out for H2O?
Nobody cares about H2O. Okay, so you could. So what you could, usually as a student, what you need to do is you need to just do each one of them. It's very tedious. So the H is a +1, the O is a -2. But see, the O over here is a okay, the O over here is a -2, and the O over here is a -2. So you could go ahead and work out each one of them, but we only care about the ones that are different. The ones that are different. Those are the ones we need to focus on. We do not care about the oxidation numbers, oops, which are the same. This is how it works for this chapter. We don't care about the oxidation numbers, they're the same. We only care about the ones that have changed. Okay, does anyone need more time copying down all the doodles? Because these are just doodles. I'm going to clear my screen unless someone hollers. Okay. Okay, so that was what we did in step 1 on scratch paper. And then we would want to just focus on the ones that change. And I'm not going to ask you to show each step. When you get to the point where you can combine them, that's fine. Okay, so now what we're going to do is separate into what are called half reactions. So you notice here, we're just looking at the nitrogen plus 5 is going to nitrogen plus 2. And then we will look at, we had 2 copper plus 1s, and they went to copper plus 2. Oh. Wait, did someone need more time for the doodles? Oh my God. Oh, I can't redo them, they're gone.
Professor, how come you put 2 Cu plus 2?
Okay, because, oh, look at that. How many copper plus 1s do we have? Okay, so that's what we're asking ourselves. How many copper plus 1 do we have?
We have 2.
We have 2.
What about the one on the right side?
We're not done. Yeah, we're going to be balancing, so we're not done. But we can do a little bit of balancing here because we know we have 2. And so if we have 2, then here, then we'll put 2 here. We're doing a little bit of balancing, but we're not done. Does that answer your question?
Yeah.
Okay. Okay. Okay, so, oh, look, it was right. Okay, it was, I wrote it down. Balanced copper because of the copper, the 2, okay. Okay, so now what we're going to do is we're going to throw some electrons in there. And the little mnemonic device I use is reduction is gain, oxidation is loss. And you also need to know about an oxidizing agent accepts electrons and is reduced, call it an OA. It causes the other reagent to be oxidized. A reducing agent donates electrons and is oxidized. Reducing agent causes the other reagent to be reduced. So I use the oil rig. That helps you remember oxidation is loss, reduction is gain. And then here's our definition for an oxidizing agent. The OA causes the other reagent to be oxidized, accepts electrons and is being reduced. Yeah, you're going to want to memorize. Okay, so now we will throw in some electrons. Wait, that was my little. Okay, so this is a +5. This is a +2. You want a charge of +2 on both sides. How can we get a charge of +2 on both sides? Oopsie, my brain is gone. Okay, my bad. Oopsie, up here. Electrons are negative. So if we add the electrons to this side, then what is our charge overall? A +2. And that's what we want. When we're adding the electrons, we're balancing with the electrons. We want to have the same charge on both sides, whatever that charge happens to be. This is a little low. Let me try a little higher. Want to have same charge on both sides, whatever that charge may be. That is what we're doing. Where's my little note to myself? Okay. Oh yeah, now. Okay, electrons are here. So that is reduction is gain. So I see the electrons are being gained. I label it as my rig. So then we're going to look at the copper. Okay, so we look at the copper and we see that here is a +2. And here, 2 times 2 is a +4. So this is also a situation we want +2 on both sides. So how do we get a +2 on both sides? We add 2 electrons. So you've got +4, 2 minus. That will add up to a +2.
Professor, how do we
Yes,
know
student.
which side to add or
I don't
subtract?
know. I don't know. I'm working it out. Yeah, I'm not gonna know. Well, okay, so let's say you don't know. Okay, did everyone copy this doodle down?
I did.
Because I need to work up here. I wonder if I can move it. It's still gonna be, oh God. Okay, no. Okay, does anyone need more time copying the doodles down here? Because I need to have more space here to answer his question. Okay, so let me answer his question. I'm gonna have to delete these doodles because I'm running out of space. Okay, so let me answer your question. Let's say I don't know. So I'm looking at this and I'm saying to myself, I have no idea. Let me do this. Wait, let me get more room. Oh well, okay. So let me do this because I don't know what I'm doing. Let me add 3 electrons on this side because I think they go there. Okay, what you're going to want to always do is you're going to want to check what your charge is on both sides.
Wait, actually, I think I kind of get it now because since the electron
Answer
is
your
always a
question.
minus.
Someone else might have the same question. No, it's a good question because you can't always just look at this and know exactly what to do. You want to be able to work it out. So just throw the electrons in and then do this. Check charge on both sides. So what's the charge on this side? That's a +5. What's the charge on this side?
+2.
Wait a minute.
I mean,
What
that's
kind of
like
math are you
-1.
doing?
-1.
That's not the same. So no. But that,
I was thinking since the electron is always a negative charge,
yeah,
and so you just gotta add it to the one with the higher charge to lower
but
it.
maybe. Oh, you know what? That's not always going to work.
Oh,
Yeah, well, okay. So I want to make sure you have a way that always works. Because it can get to be confusing. So I don't want to say yes to yours because I know this always works. Always. Your way might, but I don't, because I'm trying to think of the exceptions. No, this always works.
okay, yeah. Check charges on both sides.
Yeah, it always works. Okay, then see, now we have a +2 on that side, and we have a +2 on that side. So that's what we're doing in this step 3. And also in step 3, we do this. And from what we memorized, if this one is the rig, then nitrogen +5 is the oxidizing agent. Copper +1 is the reducing agent. So now we've assigned everything, which is also part of what we have to be able to do. Okay, there's a step 4. Just focus on step 4. Okay, so let's look at step 4. Okay, we have to have 6 electrons on both sides. So we're going to multiply this by 2 because then we can get 6 electrons here. And we'll multiply this by 3 so we can get 6 electrons here. And then we do the distributive property. And all the reagents stay on the reagent side. All the products stay on the product side. Okay, so do distributive property. And then add reactions. So that's what you're doing here on step 4.
so we distribute the coefficients of the opposite electron thing.
Now this is saying 2 times.
Since like three electron on the top and you multiply on the bottom.
This is saying, how do I get 6 electrons? You're getting so fancy.
Oh, never mind then. Okay.
How do I get 6 electrons? I multiply by 2. However it works for you, as long as you get the right answer. I only have 3, I need 6, multiply by 2. I only have 2, I need 6, so multiply by 3. And I add all these up, and I add all the products up. And then, oh, I say, okay, I've got 6 on this side and 6 on this side, I'm good. Okay, so now we have 2, 6, 2, 6. Okay, so where was the nitrogen plus 5? It was in the nitric acid, so we put a 2 in front of the nitric acid. Where's the copper plus 1? It was in the copper 2 oxide. How do we get 6 of these? We have to put a 3 in front of the copper 1 oxide. You've got 6 of the copper plus 2s. They were in the copper 2 nitrate. And so we put a 6 there. We had 2 of the nitrogen plus 2s. They were in the nitrogen monoxide. And so we put a 2 in front of the nitrogen monoxide. And we're on our own for the water. We have to balance the water on our own.
Professor, can you explain how you got 3Cu2O again?
Okay. Okay, so we know that we need 6 of these. So let's just kind of cover this up for the moment. We need 6 of the copper plus 1s. They are in the copper 1 oxide, but there's 2 coppers in 1 molecule. How do we get 6 ions? Did you follow that? Or you want me to do that again?
Oh yeah, I'm good.
Oh, you good? Okay. So you guys are going to have to be careful because this tells you how many you need, but you have to look at the formula. So you always want to make sure you look at the formula. And just to be clear, I am not going to ask you to label each, I cannot spell, label each step. I don't really care that you can label the steps. I mean, we're doing it step by step just to help you, because it has to be done stepwise, but I wouldn't expect you to know which step is which. That's not important. Okay, we have to do the water on our own. Oh, we have another little problem. We need to balance the nitrogens first. Yeah, we have a little problem. Okay, so here's the problem. Okay. You can't even see that. Okay, let's just do this. Okay. We have 2 nitrogens on this side. Let's see, 2 times 6 is 12 plus these 2. And that's how we get 12 plus 2. Okay, did you follow that? You don't need me to do that again. We need, yeah, question?
Could you do it one more time? Sorry.
Yes, I could. Okay, so what we notice is that if we go back to what we have right here, we see that we have 2 nitrogens here. That's all we have on this whole side. But we've got nitrogens from here and nitrogens from here. We've got 2 times 6. So you've got 12 nitrogens here, because there's a parentheses here. So 2 times 6, we've got 12 nitrogens here. We have 2 nitrogens here. That's how we get the 14, the 12 plus 2. So that gives us the 14. We're going to have to fix this. Is that better? Maybe we got the parentheses here. So we have 2 nitrates multiplied by the 6. And then we have the 2 here. Is that better?
Yeah, I was just confused why, like, we could say that it's 2 on one side and 14 on the other.
Oh, because we're
We gotta
not
fix it.
done. We are not
Yeah.
done. This is this is the long way to balance. This is not eeny, meeny, miny, mo time. But there's a reason we need to do it this way, because we need to know about the oxidation, oxidizing agent, reducing agent. Okay, so to show you why we're doing all this, oops, oh my gosh, I'm too bad. Okay. Okay, so this is why this is one of the reasons we're doing this. So we know which is the reducing half reaction, which is the oxidizing agent. We know which is the oxidation is lost. We know which is the reducing agent. We're doing it this way. So now we can label these. And then also, it's going to get more complicated and you will have to do it this way. But we are stuck doing some on our own. So we're going to start by fixing the nitric acid. Okay, so if we change this, we go back and change this. To 14, because we know we have 14 here. That means we'd have 14 hydrogen ions. Which means we need 14 H plus on this side. And so we will put a 7 in front. And now it's balanced. So any questions about all these steps? There's only 6 of them. Does anyone need more time to copy it down?
Those oxygen seem like they're a real pain. It's like 45 and yeah, it's nuts.
Okay, so those of you who are going to take OChem, go ahead and memorize this. Sodium borohydride and lithium aluminum hydride are reducing agents. Just memorize it, and then second semester OChem, you will thank me. If you're not taking OChem, then you just have to work it out. But for OChem, just memorize them now. You can always, for our class, you can always work them out. Okay, and then might as well go ahead and memorize these. It doesn't hurt to memorize these for this class. These are common oxidizing agents. Looks like chromium, 6-oxide, sodium dichromate, potassium dichromate, potassium permanganate, and this molecule, which you will not have to draw or anything, but this is the PCC. And organic chemists love to abbreviate. You will get used to it. So this is a pyridinium chlorochromate, also known as PCC. Let's go ahead and memorize those, and then spring 22, you'll thank me.
Is that thing the whole PCC?
Yes.
So it's 2 separate things?
Yes, yes.
What?
Okay. Okay, so okay, this is the chlorochromate part. See, no, okay, so we know what chromate is, right? But see, there's a chloro instead of one of the oxygens. This is the chlorochromate. This is the pyridium part, pyridinium part. So yeah, this is it. And you can see they're ionic because I'm not going to ask you to draw this. I'm just showing it to you now as kind of like a preface for OChem. But definitely for OChem, memorize these. And memorize these. Just do it now. Trying to prepare you for OChem. This is a little molecule. Yeah. Does anyone need more time copying that down? Okay. Okay, so I don't know if this is in yours because I found it later, but these are all the steps. Because some people like to have everything explained. So here's all the steps. Identify the compounds being oxidized and reduced, eliminate all spectra ions. I'll give you some time to copy this down. And then there's going to be some steps for when we have acid and base. So. Yeah, this will make more sense when we practice with the aqueous acid and the basic. Oh, sorry.
Professor,
Yes,
for step 3, I think it is, with like the basic or acidic.
yes.
If it were neutral, would we add H and
Oh, the one we
OH?
did was, the one we just did was neutral.
Oh. So we just add H and OH then, right? Or
No, the one, if it's neutral, we just do what's there.
oh, I see.
There, we're gonna do examples of 3A and 3B.
Okay.
Because sometimes what the book will do is it will say, balance this in acid. And you have to add the acid. So there's more steps. But we'll do an example. Does anyone need more time to copy this down? Just copy it down. Don't worry about comprehension.
So this isn't in the lecture notes, right?
I found it later, and then I had already scanned your notes. And I didn't want to rescan them because I'm very bad at scanning. And so I just put them in here, put them in mine.
Okay. Can I copy it again from number 1? Sorry. I'm good with that.
Okay. Does anyone need more time on the rest of it? Or did I go to, wait, am I going too fast, Robert?
Oh no, you're good.
Okay, does anyone need more time? Okay, I hear nothing. Okay, let's see if we can squeeze out a few neurons and do another one. Okay, so remember, this is zinc metal. So if it's zinc metal, oh my God, I just filled it in. Okay, if it's zinc metal, oh, it has oxidation number of 0. So I kind of spaced them out so you could see. So here's our nitric acid. So the nitrogen's a +5. We have to work that out. This is zinc nitrate. So we know we have to work that out because we know what nitrate is. Okay, so if we have a minus and a minus, the zinc has to be a +2. Okay, so this one, I did for this one, I just focused on my nomenclature skills. I know ammonium. Here's my ammonium ion. Oh, goodness.
Professor?
Yes.
So once we find 2 pairs of like different charges, we can just go ahead and do the half reactions.
Yes. But
For this
sometimes
class,
sometimes it's not obvious and you need to do each one and then you figure it out.
there won't be like more than, I guess, 2 pairs of.
Not for this class. Okay, so for the ammonium, what I did is I figured out, I know ammonium ion adds up to a +1. I know this is a hydrogen ion because I know ammonium is a weak acid. So I know this is H+. So I need to add up to +1. This must be a -3. Okay, so I got my zinc 0, nitrogen +5, zinc ion +2, nitrogen minus, so I got them. And what I did here is I just combined steps. So let's just kind of go ahead and go through it, even though you already saw it. I did them that separately. Okay, so this would be your next step. Just write them out. There, you never saw it. Okay. So we got a 0, a +2. to aim for a 0 both sides. So that's how I decide to put the 2 electrons here. Now I have a 0 and a 0. The electrons are here. That's how I get my oxidation is loss. The reducing agent, you want to be careful. The reducing agent goes with the oxidation is lost, but technically is specifically this reactant. Okay, then I'm looking at this one. I want to aim for a -3 on both sides. Okay, that's how I figure out I need 8 electrons. And I know the electrons are here on this side, so that's how I figure out the reduction is gain. And the oxidizing agent specifically is one of the reactants. Then we're going to do our balancing electrons. Multiply by 4, that will give us the 8 electrons. Do our distributive property. We use our coefficients to put them back in the equation. We notice we've got 10 nitrogens. We're going to have to fix that. We're going to go ahead and balance our acid first, so we get our nitrogens balanced. Okay, we had 4 times 2. That's 8. 9, 10. And then we have to do the water on our own. Okay, so we see here, we need 10 H's on both sides. We have to take into consideration there's 4 here. So we don't want to mess up the H's because there's already 4 here. We only need 6 from here. So how do we get 6 from here? By putting a 3 in front. Okay, I'll leave this on the screen. We're gonna take a little 10-minute break because we need to talk about the lab, but you need to have some oxygen into your brain. So we can start back at 12:10 and then we'll talk about the lab. Okay. Let's talk about the lab for this week. Here's your lab for this week for Beyond Labs. And then you know how to follow the directions now pretty well. Okay, so we're going to call this method 1. And we're going to call this method 2. Okay, so here's method 1. And here's our method 2. Okay, and then okay, and then this one. Okay, so we're going to do 5 trials. Do 3 trials of method 1. And then 2 trials of method 2. And so then you'll have all your 5 trials. Ooh, look at this. Okay, so it's giving you this is the grams of it, and then this is what happens to it when you add water. And so it's telling you that this is what you have when you're titrating. And it's telling you that it's oxidized. And then this one is reduced. So we kind of know some of the terms now. And then we're going to answer all the questions. Remember, the net ionic has no spectator ions. Okay. So let me and then you're going to answer number 6. Oh, that's the last one, number 6, the molarity. And it's giving you a little bit of help. That 1 mole of this solid becomes 2 moles of this. So you need to read all of that to figure out your equation. Okay, and then, okay, so now we're going to go to the Marav. That's going to be back over here. Experiment 31. Okay. Oopsie. My goodness. Okay, so this is your, from your laboratory manual. So no formal lab report. It's going to be like a worksheet. And then now you should know what some of these terms are, because we just covered half reactions. And then we're going to learn some of the terms in our further lecture. But let's just go over what's happening here. Okay, so this is showing you what we talked about in class. And your Marav saves monies by putting equal sign instead. Okay, so what we did in class was kind of similar. So we said in class that we would need to have the electrons the same. So that's why we would multiply this by 2. And then we would add up all the reactants and add up all the products. And then that would give us our net ionic, and we would cancel the electrons from both sides. Okay, so this one is getting a little bit like, oof, it's dichromate, and this is an acid. So we would want to take this one and multiply by 6. And that's how we would get our 6 electrons and 6 electrons. Then we would add up both sides, and that's how we would get our net. So this is exactly what we've been doing in class. And then we're going to talk about free energy again, of course. We'll get to that in lecture eventually. Okay, so then, they're going to give us something called volts. And this is what we're going to figure out today about this whole volt situation. So let's look at the table of the volts. Okay, so here's your table. So again, your book is trying to save the money, and so they don't put the arrows. So these are all arrows. The whole way down. And then this is telling you, for example, that if you did this reaction going this way, this would be the volts you would get. And notice that these are all positive. And then the table continues. And then we also have these on the bottom where the volts are negative. And so that's telling you what's happening when you're adding the electrons and the volts are negative. So these are the values for the volts for these. And this table is in your book, in your Marav. Okay, so then what I did, because I wanted to help you, is I went ahead and did this for you. And we'll have to figure out what's going on. Okay, so we would start with copper. It just says copper, so I'm going to put copper solid. So let's go and look in that table and find the copper solid. Where was that? Where did it go? Oh, there it is. Okay. Okay, so it's right here. Oh my God, my mouse is running into my calendar. Oh, okay. So let's just focus on this. Okay, so in our particular example, it asks for copper solid, but it's on the wrong side. So we need to start with the copper solid to become copper ion and 2 electrons. We need to take this whole thing and reverse it. So we take a look at what the book has given us, and for going this way, the book has given us a positive 0.337, but we need to reverse this. So let's take a look at what happened when we reversed this. So this is just the copper that we're looking at. So the copper solid going to copper plus 2 electrons. Look what happened to the sign. We had to reverse the sign. So when we reversed the half reaction, we had to reverse the sign, which kind of makes sense. So that's how we came up with the copper half reaction. The copper solid went to copper plus 2 electrons, and then we had to reverse the signs. We got a minus 0.337. So then we have to find the tin 4. So we go back to the table to find the tin 4. And there it is. Okay, so here is the half reaction for the tin 4. And we're going to get to use this as is. It asks us for tin 4, and here's your tin 4. So we're going to use this and just use this as is. So use as is. Okay, so we had the tin 4 plus 2 electrons goes to tin plus 2 and a 0.15. We're just going to add everything. So we're going to add half reactions. And then the electrons will cancel. They're the same on both sides. And we're just going to add the volts. And that's how we get our answer. The net ionic equation. Maybe I should make it a little higher. I'm running into my other one. Okay, questions about 1A? Okay, so let's look at B. It says we're gonna need zinc. When it just says zinc, it means zinc solid. So we go back to our table and find the zinc solid. Where is it? Oh, there it is. Okay, so there's our zinc solid. And see, the zinc is on the wrong side. So we are going to need to reverse. So here's our half reaction, but we need to reverse it. And we're also going to have to reverse this sign. So that is how we get the zinc. So we had our zinc solid going to zinc plus 2 electrons. We had to reverse it, and we had to reverse the sign. So here's our half reaction for the zinc. And this is the same tin 4, so that was the same one as above. Okay, then what you're going to do next is add them up. So you're going to add up the half reactions and add up the volts. Already did this one. So you want to get your calculators out and add up your volts. And then the electrons are on both sides so we can cancel them out. So then you're going to write your net ionic equation. I'll give you a little bit of time to do that. And you're going to write your E equals. So go ahead and do that right now. And this is what you should have gotten. Okay, so now it's asking us another question. Now, keep in mind, we're in a brand new chapter, so keep an open mind. It's asking us this. Which of the two reactions should be spontaneous? And we're going to have to look at this and compare it to this. Okay, so the difference between them is the sign. And so let's see which one is spontaneous. Ah, you must have a positive volts overall. So that means we're comparing 1A has a negative volts and 1B has a positive volts. And so I'm telling you, you need to have a positive volts overall, so then you have to put the answer in. I'm not going to do everything for you. But that's a big hint. Like I can't get much bigger of a hint. That's a huge hint. So you have to answer 1C on your own. So we referred to the table to be able to answer these questions. Okay, so this is similar. It's giving us permanganate and tin, and I put in the volts. I went ahead and did this for you from the table. Because this is getting a little hairy. So I start with the tin, made sure I had the 10 plus 2. And you can see what, hopefully you can see what happened here. Okay, so let's take a look at the tin, just the tin. So we had the, here's your tin too. And we had to reverse this. For the next question. Okay, so the next question is saying start with 10 2, which was here. So if we reverse this one, that's how we got the negative volts, because it reversed the sign of this one. And then this was from the table, the permanganate. We had 5 electrons here and 2 electrons here. So we had to multiply by 5 and multiply by 2 to get the electrons the same. Once we get this set up, the beauty of this is we just add up the volts. We just add up everything. So that's how we got this, and that's how we got the volts. Just everything add up. All the reactants add up, all the products add up. Cancel the electrons. So we're going to always have to reverse one of the half reactions. And when we reverse the half reaction, we reverse the sign. And then we just add. Okay, there's a little equation here to get free energy. Okay, so N is the number of electrons. So this is the equation, N is the number of electrons. This is a Faraday's constant after this Faraday person. That's this. And then this is the E that we got up here. So we had 5 times 2, we had 10 electrons. We put 10 electrons here. We put the Faraday's constant here, and then the volts from the adding everything up. And then the Faraday's constant does have some units. Those are the units for the Faraday's constant. And so you are going to have to do that yourself. So I set everything up for you. You just have to find out what that is. So you're on your own calculating that. But those are the units. That's the moles of electrons. That's the Faraday's constant. That's the volts. Does anyone need more time copying this down? And I am recording this for the person, so you can fast forward and then watch this part again.
Professor.
Yes.
So for this, our value should be negative, right? Because it's a negative N.
Oh, did I forget to put the negative in there? Oh,
Yeah.
oh my God, I did. Thank you for catching that. Because look at I did this. Yeah, I did this part right. Minus. I forgot to put the minus in when I was doing it by hand. Yeah, minus NFE. Yeah, it should be a negative there. So yeah, your answer is going to be negative. Wow. Oh, wow. Okay, so let's see what you're doing for your worksheet. Okay, they gave you magnesium plus zinc sulfate. Okay, so you're going to use that table that we just looked at, and your half reaction will start with magnesium. You're going to do the same thing we did in the pre-lab. So you're going to want to have one that you can probably want to do this on scratch paper first before you put it in here. You're going to need magnesium solid, and then the zinc is +2. So this is exactly the same as what we did in the pre-lab. You have to reverse one of them, and when you reverse it, you reverse the sign. But you're going to be careful which one you put where, because this is asking for the oxidation half reaction. This is asking for the reduction half reaction. And then just like we did in the pre-lab, you would put the net ionic. And the expected results, expected observations, if it's spontaneous, you would expect something to happen. So let's look at how we could do our expected observations for the pre-lab. Okay, so what would my expected observations be? Okay, let's start with 1A. Okay, let's just look. Oops, wrong place. My bad. Okay. Let's just look at 1A. Okay, so I would expect no change. I would expect no change because of this. Because what did this say? We must have a positive false overall. So for 1A, I would expect no change. Then let's take a look at B. Okay, so I'm looking at my net ionic at B. I see I have a positive. I know that's good. And I'm taking a look at what's happening here. And so my expectations would be, I would expect the zinc solid to dissolve. So I'm looking at my net ionic and I see I start with a solid, but then everything's ion over here. So my expectations would be to see that solid to dissolve. So if there's a reaction, I have to look at it and see what's happening with the phases. If there's no reaction, I would expect no change. And I base that on my volts, my E. So I have to do this for each one of these. And then because you're not doing the experiment, for the experimental result observations, you would just put not applicable. So every time there's experimental observations, you put not applicable. But for the expected observations, you have to look at your net ionic equation and your E of cell. So you're going to do this for this first one here. And then you got another one. You got copper solid plus zinc. Same idea, zinc solid plus copper plus 2. Same. Oh, you get to do number 4, same. Number 5, same thing we just did. And you get to do number 6. And there's a number 7. And then there's a 7B. Okay, so 7B is, you're not actually doing it, but you have to look at the half reactions to see if you can figure out 7B, and I'll be reasonable. And then you're going to do number 8, and you get to do number 9, and you get to do number 10, and number 11, and number 12. I believe that is your last one. Yes. That will be plenty. You get to do 12 of them. So you're going to do 12 of these. And that is your lab for this week. Ta-da! Okay, so we got plenty to do because do you have an exam next week? Well, I'll be surprised if you don't look at your syllabus. Okay, so yes. Oh, you got plenty to do. So this is worksheet style. It's still, don't wait till the last minute because it's gonna take a while to do, but that's it for your lab, plus the Beyond Lab. So you're free. You got plenty to do because you have an exam, you got to study, and yes, you have to do your yoga and do your walking and your running so you don't go insane. You're free.
Professor,
Yes.
I have a general question. So for the quiz, I noticed, so there were 6 multiple choice questions,
Yes.
and then say we missed 2, and then I see that some points are taken off as well. Like if you miss 2, it's 6 points off, but then it seems to be like 6.5 or something like that.
It should be normal points. There are the multiple choice are 3 points each.
The last one was worth only 1 point.
What? Oh, I must have messed up the points.
So I lost the first one. and
Oh,
don't know why.
I didn't change it to 3 points. Oh my God.
Hmm.
I'll have to fix that by hand. They're supposed to be 3 points each.
Okay.
That was, okay.